Here we're going to look at a couple examples of how to solve a system using the elimination method. So the elimination method essentially says you are going to line up your system so that your variables are, I guess you could say, matching. Essentially you want them to sit on top of each other. The goal is to choose one of the variables to completely eliminate out of your system through the use of old school vertical addition. What we're doing is we are essentially adding our two equations together. So here we have x, y, and a constant. Underneath we have x, y, and a constant. So we don't have to rearrange our equations in any way. Now, in order to eliminate a variable, you must have the same coefficients but opposite signs. Okay? So here, the first thing you want to do is you want to choose the variable to eliminate. So in this case, let's go ahead and choose the y. Okay, let's eliminate my y. So here, sometimes in order to eliminate, you're going to have to multiply one or both of your equations by a constant to force your coefficients to be the same. So I'm going to have my 12x minus 3y equal 21 stays the same. And when I'm looking at my bottom equation, I have 4x minus y equals 7. Well, I have to multiply this by something. Now I want an opposite sign, so both of these are negative, so I need to multiply it by a negative. And I want my coefficients to be the same. So this is a 3, so I need to multiply by a negative 3. In doing so, my top equation is going to stay the same, so this is 12x minus my 3y equals 21. My bottom equation changes, so negative 3 times 4 is going to give me negative 12x. A positive 3y is equal to a negative 21. Once you have your variable that you care about, which is your y's, having opposite but the same coefficients, you are going to do vertical addition. So vertical addition says we're essentially going to do variable minus variable. So think old school elementary addition. So 12x plus negative 12x is going to give me a 0. My negative 3y plus 3y goes away, and I have equals 21 minus 21 is 0. Now this right here is what we like to call a true statement. Therefore here, because we get a true statement, we have none of our variables are showing, we end up with infinite solutions. So that is what it looks like when you have a system that has infinite solutions. Alright, let's go ahead and take a look at this one. So again, just like before, you need to choose a variable that you want to eliminate. So in this case, let's go ahead and work with our x. So here I have x minus my 3y is equal to 1, and my negative 2x plus the 6y is equal to 5. In my top equation, I have to multiply by a 2. Why? Because I want my coefficients to be the same. So multiply by 2 gives me 2x. My bottom is already negative, so I just need to multiply by the positive. So here, this is going to be 2x minus a 6y is equal to 2. And then my bottom equation, negative 2x plus my 6y equals 5. Now I can go ahead and do my vertical addition step. So 2x minus 2x is going to give me a 0. 2 plus 5 is 7. This is a false statement, which means no solution. Alright, let's take a look at one more here. So notice in this one I have a y equals and an x equals. So the first thing that you want to do is you want to, in this problem, you want to rearrange to standard form. Remember, standard form is going to be ax plus by equals c. So we're going to move our coefficients over. So in this case, we're going to end up with a negative 2x plus y equals 14. And in the bottom equation, we're going to have x plus a 3y equals 14. So if we look at the two equations, we want to eliminate a variable. So in this case, my x's already have opposite signs. So I'm going to take my bottom equation and multiply it by a 2. So here we're going to end up with negative 2x plus y is equal to 14. And then a 2x plus 6y is equal to 28. Now that we have opposite equal coefficients, we can vertically add. So here we end up with 7y is equal to 42. Now, right here, I automatically know this is a one solution system. And the reason I know that is because once I do my elimination step, this step right here where we do the vertical addition, I still have a variable. Because I still have that variable here, that's what tells me that this is a one solution system. So divide everything by 7 and we get that y is equal to 6, hence our first solution. Now that we solved it, we just simply pick one of our two original equations and solve. Since my bottom equation is already x equals, I would use that. So I'm going to have x equals 14 minus my 3y. So x is going to be 14 minus 3 times 6. X is my 14 minus 18, so x is equal to negative 4. And here would be your second solution. Again, whenever we have systems, we write our solution in coordinate form, or in interval coordinate form, to be negative 4, 6. And there you have it, everything that you need to know about solving a system using the elimination method. So if you have any questions, please let me know. If you have any problems that you're stuck on, you need a little bit of help, go ahead and send those to me. I'd be more than happy to get you on the right track and to point out any pointers. Otherwise, I hope you enjoyed this short video, and I'll see you next time.